I added something new to the box, a duty cycle display. So right now this is saying 6.4 volts approximately, and that relates to 64% duty cycle. That's the on time. As you can see up from the display here, this is the on time down here, so you can see that this is just a little over 60% more than this. So this is about 35%, and this is 64%. And I'm doing this to show you that you don't have to have a lot of expensive equipment to do testing. This can be done with a simple voltmeter. I just added this on. This meter has 3 wires to it. You can power it by the 12 volts, and that's why I like having a switching supply here, because you can do all these add-ons. And there's a white wire, which is the sense wire, and I form a little voltage divider on the output of the op amp that drives the FET. So let's just go up and look at this on the schematic. You can get these little bare bones ones for only I think it was just about $1.25. If you want a case, it's a little more expensive. But this is the LM358, which is driving the FET. We tap off right here, and we know that voltage goes from 0 to 12 volts to drive the FET. And so we have a voltage dropping resistor. This is to provide basically filtering, and we have a capacitor right here. So you're charging and discharging the capacitor. If your capacitor is large enough, you get a fairly stable voltage here that you can read. Now we have 12 volts here. I have a 20K resistor, and internally this is about 124K sense resistor. So that comes out to about 10 volts here. So if it was on all the time, we'd see a 10 volt voltage here and 10 volts being displayed. And this capacitor can be anywhere from 1 UF to 4.7 microfarads. It doesn't really matter. It's more or less the response time. And if you didn't want to have this meter, if you have a digital meter, you can still have just the resistor here. Just say, have it at least 10K. And then you can put a 20K pot down here with the capacitor across that voltage divider. And then you could just adjust this with just feeding the power supply in 12 volts and adjust the pot so you get a 10 volt reading. And then when you place it on this point, you'll get the duty cycle. So it's really very convenient. And if you just want to put a resistor and a capacitor combination in series, this voltmeter will measure the average voltage across the capacitor. So you could look at your display voltage, say it's 80 volts, and what you're reading is 40 volts, then you have 50% duty cycle. So it's fairly simple, and like I said, you don't need a lot of test equipment. Just a good DVM will make it run.